11 through 20. Questions. Yeah, well, it was from the night before. Let's do tonight. 11 through 20.
I did the one already that was due last.
Number 20. Thank you, Wyatt. Number 20. Number 20 gives you this graph. It looks like it goes up to 3. It goes down to -3. It crosses at 2. Goes over to 7. Down to 3. Something like this. Close enough. And so you have to find, so this is velocity. And it says part A, find where the particle is at the end of the trip and then find the total distance. So where it is at the end of the trip is what? But what's that called? Starts with a D. Displacement, as opposed to the total distance, which is when we have to do the absolute value. So either way, I'm going to find the area under these shapes, right? Here, 1/2. Height is 3. Base is 2. So 3. This has a total area of 3. Agree or disagree? Thank you, because that's right. Okay, now the other one is under there. It looks like a trapezoid, right? 1/2. The 2 bases added together. What is this base? 3 to 6, so it looks like 3. I'm looking in the book because mine's not, but this was. I'm looking, yes, this and this. And then the height. This is 5. This is 3. Do I know what one? No, I don't, and I don't want to. Okay, 4. This one's 12. Area here would be 1/2. It looks like 7 to 10 is 3, and then it's up 3. So 9/2. So it depends on what you're looking for. If you're looking, part A is the particle at the end of the trip, where it is. So that's displacement. So for displacement, it's going to be 3 minus 12 plus 9/2. It takes the signs into account. Negative 9/2. Did we? Oh, you're right. So where did I end up? So this is the displacement. So where did I end up if I started at 2 and I'm backwards? Here's 2, and I move backwards 9/2, which is 4.5, right? So 2 would put me at 0. Now I got another 2.5 to go backwards, so -5/2, is that what you said? So that's where I end up. Yes. No, that's part A. That's where the particle is at the end of the trip. Because what happens is I start at 2, okay, and I move to the right 3. 1, 2, 3. That's this first triangle. Then I move back 12, but then I move back to the right 5/2, and 9/2, and I end up right here. Shut up, Dylan. Do you have Josie's phone? Did one of y'all have Josie's phone and she's out? She went to her car. Okay. So part B is where you'll make it absolute value. So it'll be instead of minus it'll be 3 plus 12 plus 9. Yes. It's the sign. If it asks you for total distance traveled, it's absolute value.
And so the reason why the answer is not negative 9 over 2 is because we started it.
Correct. If we had started at 0, this would be the answer. It'd be negative 9 over 2. But because I started at 2 and not at 0, I had to take that into account.
So, just have each of the answer, and then since we started at 2, subtract the value. So we get, if let's say
we added the 2.
We added. Yeah.
Mm-hmm. Which other one did y'all say? 12? 11. Oh, this is a particle motion. Recall that acceleration due to Earth's gravity is 32 per second. From ground level, a projectile is fired straight upward with velocity of 90 feet per second. What's the velocity after 3 seconds? So this is initial velocity. Okay, that's what it starts out. It's initially fired. Velocity changes, right? If you shoot something out of whatever you're shooting this out of, the velocity is not constant, right? It's not staying the same as it comes out. It's going to slow down due to many, many factors. But this is initial. So what this tells me really is that at time 0, because this is acceleration as a function of time. So at time 0, the velocity is 90. So what I'm going to do, I need a velocity equation, right? Because I want to know the velocity after 3 seconds. So I'm looking for v of 3, right? Okay, so I need to do, remember, because it goes acceleration, velocity, position, and that's acceleration. So velocity is going to be 32t plus c. Are y'all following me on that? And then I'm going to use what I know. So 90 equals 32 times 0. So my velocity equation is 32t plus 90. And I'm thinking that needs to be a negative 32. Well, because if you're talking about the force of gravity, gravity makes you fall, right? So it should be negative. So does it work? What's it say? After 3 seconds. So using that, what's v of 3? Negative 32 plus 90. This will be negative 96 plus 90, which is, please be right, negative 6. We're in feet per second. Yes. You have to know that it's negative. The gravity is always going to be negative here because it's falling down. But gravity has a negative impact on it.
So we're slowing down by negative 6. But we're slowing down by 6.
Well, remember, speeding up and slowing down has to do with the acceleration. And yes. If you're shooting down, yes. But if you're shooting up against it, right.
So we are slowing down by 6, or we're slowing down by negative?
Velocity is not, so the speed here would be, but this is the instantaneous speed at that second. So it's not the, you know what I'm saying? So that's not the rate that it's changing. I don't know. They did something to it. 6 feet per second at that instant. At that instant. Right. That changes, right. It's kind of like that tan line that's right here. So how do I tell when it hits the ground? So it hits the ground when velocity is 0? I don't know, I'm asking.
Gravity is position. Well, if gravity isn't working, your velocity will be.
Gravity's never not working.
You have a.
Well, like, it's when it hits on the, it's probably gonna be.
I'm going with position too. You can hit 0 velocity while you're still in the air. So here's what we're going to do. I want to go to position, and I want to know when position is 0, because position tells me where. And if it's 0, it's on the ground, right? What are y'all grinning about? I feel like y'all are like being very mischievous. Are they squirting you with that bottle? Negative 16t squared plus 90t plus c. So now the problem is I need to be able to find the c. So I need some value. So go back to the beginning of the problem. What does it say? Recall that the acceleration, but that doesn't help me. From ground level, a projectile is fired straight upward with a velocity of 90 feet per second. Does that help me? If it's fired from ground level, that means the position at 0 seconds is 0 feet, which means 0 equals c. So my position function and now I need to know, when does this equal 0? I know it's at 0. That's one of the solutions, right? This turns into like an algebra 2 problem. What's the GCF of those two?
Oh, wait, how did they know?
I don't know.
You can at least take up 2.
Yep.
45 divided by 8.
Zero.
5.625 seconds. So yeah.
Why did we check out it?
Just trying to get it down so we could fact, yeah. It all comes back to algebra. It always does. What? Well, I did. I plugged in 0 here, and if I plug in 0, I get 0 plus c equals 0. So I plugged it in to find my c. When you plug in to find out, the question asks when does it hit the ground. So when is the position 0? So when does the equation equal 0? And that's all. Well, there's t equals 0, but that's your starting point. So it doesn't hit the ground then, but it is at 0 then. But I'd already taken that into account. Right. For part C, you really don't even have to do any math with it. When it hits the ground, what's the net distance it has traveled? So you're talking about displacement, 0. I mean, if it hit the ground and it started at the ground, then whatever it went up, it fell back down. That's right. So that's 0. And then part D says when it hits the ground, what's the total distance it has traveled? So that's different. So it hits the ground at this time, yes? So I'm going to do the integral from 0 to 45 over 8, right? That's not what they did. When it hits the ground, what's the total distance that it has traveled? I would say this is a calculator problem because this is going to have to be one of these split up integrals, right? If I think about what velocity looks like, where's velocity? Where's my velocity equation? Negative 32t plus 90. It's going to look like this, right? You agree with that? So at this point where it's split, where it hits the x-axis, which happens to be minus 90 divided by negative 32. What is that? Somebody do 9 divided by 32. 2.8. This is 2.815, whatever that is, that point here. So I would have to split this integral. I need the integral from 0 to that point of velocity because that's positive, right? And then I would need to come here. I'm assuming it's going to be the same thing, Sarge, but I'm going to subtract this. And what did it have to go up to? 45 over 8.
It's 2.182.
Two point eight. What? Okay. Sorry. All right. I know y'all are being really ugly to each other. Okay. Let's take a break in between before we start area between two curves because 17. We did. Yeah, we did that one in class. No.
I'll bring it back. I'll always have to bring it back. Thanks, first. I got lasers. Like 20 of them. Oh, that was definitely like people to get. So. I was thinking about driving a dirt bike too.
This is what we're doing. We're looking at finding the area of something that looks like the shaded area there, as opposed to just down to the. Yeah, she'll catch up. As opposed to just down to the x-axis, which is what the integral does for us. We're talking about an area between two curves is bounded by the two curves. So if you think about it, logically it makes sense as to what we're doing. So yeah, probably a lot. You probably get arrested. You'd have that mugshot you always wanted.
Wait, what if I put
I don't know. I would not do that.
We have to have a secret.
Okay. Here's what we're going to have to do. There are going to be several things that we're going to have to do as we go through this. One, to find this area that's in blue, we'll have to know what these points are, right? Because we'll have to know where to bound it. So that's going to be one thing we're going to have to find. Now, how do I find where two graphs intersect? You set the equations equal. So finding intersections. Tuesday. By setting equations equal, and you're looking for the x values, right? Say right, that's right. All right. Now, if I find those bounds, if you think about this for just a second, I need another color. Bless you. All right, let's say I took this green graph right here, right? If I found the area under that curve from those 2 points, well, what I'm finding is all of this, right? Then if I took this light blue graph here and I found the area under it, then I'm finding all of this. Do you agree? Then you can subtract them. That's correct. Yeah, I'll give you a second.
Yeah.
It's not a hard concept. It's harder to do. It's the calculus. I mean, it's the algebra of it. It's going to be the hard part.
I can't believe you assumed it. You assumed it was very close.
Right. So the area between the two, you would do the integral of the top minus the bottom curve. But this is gonna be your intersection points here are gonna be found. Well, this is all together.
So which one?
Yeah, which is the same thing as having them split. Remember those properties of integrals?
So which one?
That's the same thing.
Which one is the top one?
The one that physically sits on top of the other one. So that's the top, that's the bottom. Okay. Now, we will get into some really complicated ones who they switch which one's on top, when and where. And that's a whole other ballgame. You're gonna have to draw pictures for these to know. Right. This lesson or in this chapter? Volumes of power. Revelation. It's not, it's
I'll test
not.
it.
Huh?
I'll test it.
Very. Area between two curves, heavy. The volumes, rotational volumes like that. Sometimes it's part of an FRQ. It's always a couple multiple choice, but this is a biggie. Differential equations and this chapter are huge. But that's because this is the applications of integrals. This is why we learn integrals, is what we're doing with it now. Right. This puts it all together. And really, aside from what area between two curves, then we get into volume and we're done. Like that's going to be it. So, calculus. We're not far off, but
You're worried, and we're arguing. Oh, last chapter.
well, I've skipped over a lot that I have done before that, I mean, I'm using a new philosophy now to just focus on what's tested the heaviest and see nothing. Yeah, there you go. All right. Let's look at one. Okay, I'm going to do this example in the book. I'm going to give you the graph for this one. Look, they're all shades of blue.
Do you recommend taking top one over again?
Depends. I didn't take it over again. Here's the thing is It depends on if you want what your major is and if you want that GPA boost.
Because I'm majoring in biochem.
Well, I majored in math, but they let it. But the thing is, you're only getting out of Calc 1. You go into Calc 2, and you're still doing what we did in AP Cal. I feel like Cal 1 and Cal 2 were what I did in AP Calculus. I didn't hit stuff I hadn't seen until I got beyond that. It's like the Algebra 1 of high school, in my opinion, yeah. Well, that's what I'm saying. It depends on what you want your... This is sin x. This is secant squared x. And I want to find the area between the two curves from x equals 0 to x equals pi. Now notice these don't intersect or anything like that, so I don't have to find any intersection points. All of these problems are different, which is why I said you have to draw them out. So this question would look something like, find the area between the curves, y equals secant squared x and y equals sin x, from x equals 0 to x equals pi over 4. And it would be up to you to graph it and to look at it. This would be a calculator problem, yes. Yes. So here's the area that I'm looking
So
for.
why did you pick those two places?
It said from 0 to pi over 4. Mm-hmm. So I'm looking for the integral. Yep, it's top minus pi. That's all it is every single time. So from 0 to pi over 4, I don't have to divide this one up. I don't have to do anything of the sort. This is a very, very straightforward one. If I do secant, that's going to take me all the way down to the x-axis. And if I do sine, that's going to give me this part. So if I do the whole thing minus this part on the bottom, that should give me the shaded area that's left. They told me that was defined in the problem from x equals 0 to x equals pi over 4. All right, so I'm going to do secant first, right? Because that's on top. Like literally on top up here, minus the bottom function, which is sin x. So the one before, they didn't give me an interval to do. They just said, it would just say, find the area between the two curves. And you'd have to find those two, right, because the area between the two curves, right, to find those points. Possibly, or maybe a quadratic and a cubic, just depends on whatever they give you. We'll do a bunch of examples, don't worry. All right, this becomes a little bit easier now. What's the antiderivative of secant squared? Tangent x. What's the antiderivative of negative sine x plus cosine x? And I'm going to evaluate both of these from 0 to pi over 4. We'll get into some pretty... Can we just leave it what? Yes, yes. Yes, that's what I'm doing. Minus the tan of 0 plus the cosine of 0. All right, so here's that unit circle, all that good practice we did with that unit circle. Tangent of pi over 4 is 1. The cosine of pi over 4 is square root 2 over 2. The tangent of 0, tangent of cosine, the cosine of 0. I said that backwards. 1 minus 1, so it's just square root 2 over 2. Pretty easy so far. So far. What's the answer? Find the area of the region enclosed by the two functions. This is your last easy one before I go a little bit. Quadratic and a linear. I just want enclosed by the two functions. Separate which intervals? If you want to, if it makes it easier for you, you certainly can. Does everyone's area look like this? Okay, so this is one that I do have to find those intersection points. I need to know where these two are intersecting so that I know where to set my bounds.
Why did you choose that point instead of one?
Do I? Just between the two. Bounded by the two graphs. There's that daggum algebra again. I got from -1 to 2. Is that what y'all got? So I'm looking for the integral from -1 to 2 of the top curve minus the bottom curve. Bless you. Yes. I just wanted to show you that I'm still doing top minus bottom. Things haven't gotten funky yet. If you get confused, think about what it is that you're finding and shade it. If I find the area under the parabola, it'll be what's in blue, right? But it's going to include this. If I do the area under the line, which is going to be negative area, or part of it, it's going to be this. So if I take the blue and subtract the yellow, I should be left with the purple. Say again? You can do it all in one go. 4.5, I think. I don't know what you got.
Let's go.
Yeah.
I like it.
I don't mind these so much, the volumes I do. But
Why is it? Okay, I thought you have the variables one time you add the x and you get negative x squared plus x plus.
well, I just put them on the other side so that my leading coefficient would be positive, so it'd be a little easier factor for me. So I move both of these instead of moving the x. Remember, you always want to try algebraically, if you're factoring or anything of the sort, try to keep your leading coefficient positive. It'll help you.
So
Yes. I'm not going to work this one, but while y'all finish copying that, let me just show you. You'll encounter this on your homework, and I just want you to understand what it is you do. You have one that does something like this, and you're asked to find this area and this area. Do you see that your top and bottom functions are switching places here? So you'll have to do this one. You will have to do two separate integrals for. You'll go from here to here with the blue minus the pink, and then you'll go from here to here, pink minus blue. That's because they switch which function's on top. This is not always the top function, and it's always got to be top minus bottom. So if your top and your bottom switch places at any point in time, you got to split that integral up there. So you see this is one, and then this is another. So here it's on top, but here it's on bottom. Switched up. All right, let me tell you what I want you to do. This is whenever we get into the meat of calculus. I love it. I will hold off on with respect to y till Monday, because that gets a little tricky. So let's do Tuesday. Let's do numbers. There is one, number 10. I told you you have to draw pictures for these. The pictures are given to you until you get to 15. 15 is where you have to start doing your own pictures. And these 15 through 18 are non-calculator. And then, so I'll save the harder calculator ones from Tuesday. But number 10 looks like this. This is why the pictures are so important. And it's important that you understand what it is you're looking for. 10 does this, and this is y equals x squared. And then it's got this line that comes through like this, and this is y plus x equals 2. and you're asked to find this area. Any ideas what you might do? You don't have a top and a bottom curve. No, because this is curved. Add what? You do. You're going to add something together. That's exactly what you do. Good job. If I divide this out here, the area under this curve, whatever this point is, this is x squared. So I can just do the integral from 0 to whatever this is, that intersection point of x squared. And to it, if I find the area under this one, solve it for y, right? From the intersection point to whatever this 0 is of 2 minus x, and add them together. This is just more of a straightforward one. It's not between two curves. It's just, can you interpret what it is you're finding? It's more about, do you understand what you're finding when you find the area under the curve? That's all I got for you today.